Hello, this is Mr. Long, and this will be another video on stoichiometry. So just to review on what you have taken notes on so far, we wrote down our definition, and we wrote down our indispensable roadmap of where you should first go on any problem and diagram in your head which way you are going. And you are to memorize this whole thing, but remember it's a mirror image of itself, so you just have to memorize half of it. And you start with memorizing the central road right here. And anyway, periodic table, coefficient ratio, Avogadro's number, 22.4 liters of a gas and 1 mole of that gas. So anyway, and on the second page here, we did moles A and mass A problems, and mass A moles A problems. We had a couple of examples here, and we went on, and then we balanced this combustion reaction right up here, and it took us a while to do it, but we got through it. And then we did moles A, moles B problem, the central part in our central road, the stoichiometry roadmap. And so we did our example there, and actually these are really quite simple, so don't let them scare you. And then we had a couple of homework problems. This was one homework problem here. Feel free to pause this anytime that you want. We had a second homework problem here about moles, conversion to moles using the balance equation here. And we had a third homework problem with H2S and the combustion here that's involved here. So anyway, now on the next video we started mass problems. This is a more meaty type of problem. You go from one end of the roadmap to the other, which is right here. And in our first example we had a combustion of propane example, and we went through the steps. We calculated our molar mass. You have to use the periodic table, make sure you have that out. And then we did another example, and we went through that, and that went all right. And I want to make sure that you get the homework that should be assigned with that. So here we have a couple of homework problems with that. We have 2Na reacts with Br2 to produce 2NaBr. And so how many grams of sodium bromide, which is right there, can be produced from 52 grams of Na. So sometimes it's easier just to put what you have above in the balance equation and where you're going, what is your question mark. Sometimes it's just easier to see that way. And then we have homework problem number 2. Given this reaction, KO2 reacts with water to produce O2 plus KOH. And then what mass of KO2 will produce 117 grams of O2. So you can put your numbers up here if you want, and that's fine. Now we're starting off today with example 3. From this reaction of B2H6 reacting with O2 to produce HbO2 plus water. This is not balanced. Now I do not leave very much room here, but we can still do this. So I'm going to put B, H, and O here. So we've got to have a balanced equation. So we're going to balance this together. We see 2 borons on the left and 1 on the right. There's no subscript. We see 6 hydrogens on the left, and then we see 1 plus 2 makes 3 hydrogens on the right. And then we have 2 oxygens on the left, and 2 plus 1 makes 3 on the right. Now remember that you save oxygen for last, hydrogen for next to last. So that leaves boron. And of course the obvious thing to do is put a 2 in front of HbO2 to try to even this out. Now you remultiply. 2 times 1 hydrogen is 2, plus this 2 will make 4 hydrogens on the product side. 2 times 1 boron is going to be 2, and that's good. 2 times 2 oxygen is 4, plus that 1 is going to make 5. So we'll put 5 right there. And we can see now that we're short only 2 hydrogens on the right, and it shows we need to put a 2 in front of water as a coefficient. 2 times 2 is 4 hydrogens, plus 2 times 1 is 2. 2 and 4 make 6, and then that's good. And then 2 times 1 oxygen is 2, plus the 2 times 2, which is 4, which makes 5. So we're good there. So let me look at this again. So 2 times 2 oxygens will be 4, plus 2 times 1 is 2, so 4 plus 2 is going to make 6. That's what we need, is a nice even number. So we want to put a coefficient in front of O2 on the reactant side, so we put a 3 there. 3 times 2 is going to make 6. So there we go. Now it's balanced, and put your 1 right there. So got a 1, a 3, 2, and a 2. So what mass of O2 will be needed to burn 36.1 grams of B2H6? Okay, well, we're going to start with this right here. So we're going to start with 36.1 grams B2H6. I wish I left myself some more room here. And we're going to draw our lines, and we're going to have grams of B2H6 equivalent to 1 mole of B2H6. Now we've got to figure this out, so we're going to look at our periodic table. So get your periodic table out, take a look at this. Boron has a mass of almost 11, so we're going to make things really easy. So boron is going to be equal to 2 times 11, which is equal to 22. And then we're going to have hydrogen, which has a mass of 1 times 6 is equal to 6. It's 28 for your molar mass approximately. So we're going to put it 28 right here. So now we're in moles of B2H6. Now we want to use the middle of the road map, moles to moles. So we're going to put moles of B2H6, and we're going to moles of O2, and we look at our balanced equation. We have 1 mole of B2H6 and 3 moles of O2. So we got the moles, and now we're going to do grams of oxygen. So in 1 mole of O2, now we don't have to write the simple part down because we know the oxygen is 16. Times 2 is going to make 32. 32 grams of O2. Okay, and we can cancel out our units. And I want you to pull your numbers over. Again, I apologize for not leaving enough room. It's equal to 36.1. Ones drop out. Numbers on top stay on the top. This is times 3 times 32. And numbers on the bottom stay on the bottom. It's like multiplying a fraction. And then you got to pull out your calculator. And so I'm going to get out my phone calculator here. So here we have this. Okay, so we're going to put in 36.1 times 3, and you got 108.3 there, times 32 gives us that. And then we want to divide it by 28. It gives us 123.7. We're going to round this to 124. And we're in grams of O2. Put a nice little rectangle around it like that. And there we go. Pause it, go back. Forgive me for when I stumble. I'm going to do that a lot. And so there we go with this problem, mass problem. Let's look at example 4 here under mass. How many moles of water are produced using the same balanced equation from 19.2 grams of B2H6? So let's do this. So again, I did not leave myself much room. 19.2 grams, B2H6. If you guys are at home, just please skip a line there to make it better. And so we're going to have to calculate moles of B2H6 first. So we're going to have we're going to have 1 gram. We're going to have grams of B2H6 here, equivalent to 1 mole of B2H6. Now we did calculate the mass previously, which was 28. So we're going to put 28 right there. Grams of B2H6 are equal to 1 mole. And now we're going to go to water. So our moles of B2H6. So we're going to go from moles of B2H6 to moles of water. Now you got to look at the balanced equation. In front of water is going to be a 2, and in front of B2H6 is a 1. So it's a 1 to 2 ratio there. And then we've got our last step in 1 mole of water. Again, this is easy. That's going to be 18 grams of water. Now we cancel our units, right? So these grams cancel, those moles cancel, these moles cancel. Now what do? We pull our numbers over. So we're going to have 19.2 times 2 times 18. And this is again going to be over 28. So let's see what we can do here. Get out a calculator again. Okay, so here we go. So we do 19. Let's clear this out, shall we? Okay, 19.2 times 2 is that, times 18 is that. Now divided by 28 is 24. We'll call it 25 now. And I really hate just running to the whole number, because all my life I've been running to the 10th and the 100th. But it's okay. We're going to make our life a little bit simpler here, because this is hard stuff. Okay, so we've got 25 and more grams of water. We want to do that. And if any of you guys see a mistake in this, well, you be sure to get on my mind and let me know. Okay, so there we go with 2 more of these problems, mass problems. And now we're going to example 5. This is already balanced. You get potassium chlorate, undergoes decomposition by heating. The triangle with the arrow means you're heating this to produce potassium chloride plus oxygen. So what mass of KClO3, so we're going to put the question mark right there, will produce 95 grams of O2? Okay, so what we're going to do, and I left myself a little bit more room here, so that's good. And so we're going to start with what we're given. We'll start with 95 grams of O2. And if you're going to look at your roadmap, hopefully you got it memorized. Turn grams to moles. You use the PT periodic table. But feel free to go back and refer to your roadmap whenever you want. Because I'll tell you, when I first started learning this stuff, I needed that roadmap. So there's a ways back here. So you just go back to your roadmap, take a look at it, and that's fine to do. So anyway, we're down here, and what mass of KClO3 will produce 95 grams of O2? So down here we will have, let's see here. Can we do a better job of focusing? Yes, come and focus. There we go. Okay, we're going to have grams of O2, so if you want to look it up, you can look up oxygen. The mass is 16. 16 times 2 is going to be 32 grams of O2. Now, this is perfectly legit, and I really sort of prefer you guys to do this. Oxygen is equal to 16 times 2 is equal to 32. And this is equal to 1 mole of O2. And now we're going to go from moles A, which is moles of oxygen, to moles of potassium chlorate. So line up your units, whatever is up here. If it's a zebra, the zebra will be down here in this next step. So we're going to equate moles of O2, and we're going to go to moles of KClO3. And so let's look at our balance equation. 2 in front of KClO3 and 3 in front of O2. Okay? And now we're moles of KClO3. And now we're going to go to grams of KClO3 using the periodic table again. So now we're going to add this up for real. So anyway, so in 1 mole of potassium chlorate, KClO3, we're going to have so many grams of this. So we got to do this here. So K is equal to, so let's look at the periodic table, 39.10, we'll call it 39. 39 times 1 is equal to 39. Chlorine is equal to, now chlorine is always right in the middle. We're going to call chlorine 35.5. So it's 35.5, and we only have 1 times 1 is equal to 35.5. Then we have the big O. We know that 16 times 3 is equal to 48. So now we're going to whip out that calculator again. So here we go. And let's clear this. So let's add 39 plus 35.5 plus 48. 122.5. So we can put 122.5 here. We're in grams of potassium chlorate. So we can do that. And now what's our next step? It is to cancel our units. So grams of O2 cancel. Moles of O2 cancel. Moles of potassium chlorate cancel. And they're left with grams of potassium chlorate. So we have that, and now let's go ahead and pull our numbers over. So we're going to have 95 times 2 times 122.5 divided by 32 times 3. You guys want to pause me and go ahead and figure it out? That'll be good. Okay, so let me bring my calculator over here again. So what we'll do is, here we go, 95 times 2 is 190 times 122.5, and so I'm just going to pull this over, 23,275. And then you could do 32 times 3. So 30 times 3 is 90. That's going to be 96 right there. Or what you can do is go ahead and divide it by 32, and you get your number there. And then you can divide that number by 3, and you get 242 right there. It's equal to 242. And now we're going to be in, so we can call, since we didn't have a decimal, so we'll call it 242.5, and we're in grams of KClO3. sure do get messy. Okay, I hope you guys do a much better job than me on getting this done. And so there we go, that's our answer. Okay, last one. Example 6. What is that buzzing here? Oh, I bet I know what it is. Okay, so here, how many grams of CO2 in this combustion problem would be produced from the complete combustion of 225 grams of C5H12O? So we see we've already done this. We have a 1 here, 15 here, 10 here, and 12 there. I almost left it for you guys to balance, but no, we'll go ahead and take it as is. And so we've got the question mark over here by how many grams of CO2 will be produced from the complete combustion of 225 grams of C5H12O2. All right, mass. So where do we start? With what you're given. So we're going to start with 225 grams of C5H12O. And now I got lots of room. Okay, so we're going to have grams of C5H12O equal to 1 mole C5H12O. I guess we might as well go ahead and just figure that out. So carbon is equal to 12 times 5 is equal to 60. And then we got hydrogen is equal to 1 times 12 of these. And that's equal to 12, so our molar mass is 72. Put that 72 there. Now in 1 mole, so we're going to equate now moles of C5H12O. Oh, come on, I'm supposed to call my mistakes. There's one more mistake here. Oxygen. Oxygen is equal to 16 times 1 is equal to 16. So that's going to be 78, 88. So let's put 88 right here. Okay. Now I think we got that. So we're going from moles of this to moles of CO2. So look at our balanced equation. So we got 1 here for this. And for CO2 we have a 10 moles CO2. Okay, now in 1 mole of CO2 we're going to have so many grams of CO2. Now I know what that answer is, but we'll show it anyway. Carbon is equal to 12 times 1 is equal to 12. Oxygen is equal to 16 times 2 is equal to 32. That makes 44. Put 44 grams right here. Okay. Now I think we got that. So let's go ahead and cancel our units. I think I like that part the best. Just cancel them out. Now pull the numbers over. So we're going to have 225 times 10 times 44 divided by 88. The ones drop out. So let's go ahead and use our calculator here. So we got 225. Times 10 times 44. It's 99,000 divided by 88. 1,125. And we are in grams of CO2. Like that. So we're going to make lots of CO2 in this chemical reaction. Okay, so we got 3 steps. Use your stoichiometry roadmap, use a periodic table, use a calculator, show your work except on the most simple of molecules or compounds, and pull your numbers over and show that, and then put a nice little rectangle around your answer. And there we go. So that's 6 examples. And so, oh my God, it's homework here. Goodness gracious. Okay, and I've already written this out, so all right, my part's done. So this is homework problem number 3 under stoichiometry, and you've got 39.02 grams of barium chloride are reacted with silver nitrate, excess silver nitrate. How many grams of silver chloride are produced? So I'll put the 39.02 grams of barium chloride, and the question mark goes with silver nitrate. So, and for the reacted with this, how many grams of silver chloride are produced? Right there. Okay. On the next question, you got the formation of ammonia. N2 plus H2 produces ammonia. So, you got your question, how many grams of NH3, right there, can be produced from 21 grams of N2. 21 grams, right there. And then we've got homework problem number 5, homework problem number 6, and that's 3 steps. So, pause this, write all this stuff down, get your homework all together, get your notes together, because I want to see the notes and the homework problems. And this is just one type of stoichiometry problem. We got a lot of others to go through. Okay, because we got to go calculate volume at STP, or maybe go from mass A to volume B instead of volume A, or we can go from mass A to Avogadro's number of particles B, or number of particles A, and then we can do other things. Let's take this a little bit at a time. And so, anyway, there you go. And I'm going to call it right there.